In this video, we're going to cover functions, and this is going to be relatively quick because functions are a little bit more abstract and we don't really use them directly too much. It's more so to define things. So a function from A to B, which we write A arrow B, so elements in A get mapped onto elements of B, is a subset of some relation, where each element of A is mapped to exactly one element of B. This means everything in A goes to exactly one thing in B and no more. We can think of this as input-output. So if you've ever had a course with Dr. John Alderetti here at SFU, he is Mr. Input-Output. Everything is input-output with him. I say this in jest, but it is kind of a fact. But that's what makes John John. So I have an example here. Here's a real example from students to letter grades. Imagine I have 4 students in some set, Greg, Carol, Susan, and Mark, and I have 5 different letter grades you can give. Let's simplify this, A, B, C, D, and F. We could take a function, F, and what we could do is we can put in some student, and then what's going to give us out a grade. So it's kind of like an Excel sheet. I put in the student, it tells me what grade they got. So in this example, Greg gets an A, Carol gets a C, Susan gets a B, and Mark gets a C. So we can see the arrows going from each person to each letter grade they got. So the thing that you put into a function in the brackets is called an argument, and the thing you get out is called its value. So in this example, if we take f of Susan, where f is the function that maps students to letter grades, we see that f of Susan is equal to b. So Susan gets a grade of b, and I've highlighted this in blue here. With functions, I always recommend drawing these things out because when you draw them out, it becomes very clear. So, I have a question. Which of the following relations are functions? We have A is A, B, and C. So I'm going to draw this out. And B is 1, 2, 3, and 4. So you can try this yourself, but in order for something to be a function, every element in A has to go to exactly one thing in B. So in the first one, R, A goes to 1 and B goes to 2. Is this a function? The answer is no, it's not a function because we need C to be mapped to something, but C is not being mapped to anything, therefore this relation R is not a function. Okay, what about S? In S, we have A goes to 2, A goes to 3, and B goes to 4. Okay, this is also not a function for 2 reasons. The first reason is just like the previous one. C does not get mapped to anything, but another reason here is that we have A going to 2 things, and this is not okay. For a function, each thing in A, so A, B, C, can only map to one thing in B. So A can go to 1 or A can go to 3, but not both. So that is why S is also not a function. Finally, the last one, T. Okay, A goes to 3, B goes to 2, and C goes to 2. Is this a function? Well, yes it is. It's a function because every element in A is being mapped to something, and specifically each element in A is going to exactly one thing. So T of A is 2, no sorry, T of A is 3, T of B is 2, and T of C is 2. So this means that A goes to 3, B goes to 2, and C goes to 2. It is perfectly okay for B and C to map to the same thing. It's like in a class, 2 people can get the same letter grade. It's okay. So that's just a basic intro to functions. Next, we're going to talk about different terms for these, domain and range. So f goes from A to B. This is a function from A to B, so you have some elements in A, you have some elements in B, and there's a mapping between them. The domain of a function. The domain is just everything in A. So those are all the elements in A. A itself is the domain. So in the previous example, we had ABC as the domain, so the domain of A is just ABC. The range of a function, is everything that the domain gets mapped to. So if we take a look in the previous example here, allow me to clean up some of these marks here, but I think it's good that we take a look at this. A went to 3, B went to 2, and C went to 2. So A, B, and C, this is the domain of our function, and the range is 2 and 3. So the range only includes the things that the domain gets mapped to. So 1 and 4 are not in the range because there's nothing in our domain that takes that element to 1 or takes that element to 4. So the range is only the things that are being mapped to. So in this example here, I have another function. So I'm going to draw this out. I have, look, it's the same thing. It's A, B, C, and A. And I have 1, 2, 3, and 4 and B. And I'm told, okay, F is A1, B2, C4. So let's draw this out. A goes to 1, B goes to 2, and C goes to 4. So the domain is just ABC. This is the domain of the function. These are all the elements in our initial set that we're mapping things from. And the range includes 1, 2, and 4. That's the range. Because we have elements A, B, C mapping to 1, 2, and 4, so that's the range. And we can write this down here. The dom of f, the domain of the function f, is the set ABC. The range of the function f takes the value of f of a, f of b, f of c. So this is basically what each of these are mapping to. A goes to 1, B goes to 2, C goes to 4. Therefore, the range of the function is the set 1, 2, 4. So that's domain and range. Now we have some terms with these functions. So I highly recommend drawing everything. Every function we have in the course you can draw because there's not that many things in each of the sets A and B that we're going to deal with. At least I'll make it simple enough so that way you can draw them. Because we have terms like this, on to, 1-to-1, and a 1-to-1 correspondence. So we say that a function is on to if the range, everything in the range is equivalent to the set B. So if we have A going to B here, and we have our function from A to B, which we have represented here, we see here that everything in B is being mapped onto from A. So the range includes everything in B, therefore this function is what's called onto. Here's an example of a function that is not onto. This function on the right is not onto because this element here, this is in B, but it's not in the range. So because there's one element in B that's not in the range, it is not onto. The next one we have is called 1-to-1. And a 1-to-1 function just says that every element in the domain maps to a unique element in B, or a unique element in the range. So in this case, we only have one thing mapping to the top element and one thing mapping to the bottom element. So because these are unique, this is 1-to-1. On the right side, however, this function is not 1-to-1, because if we call this AB and we call this first element 1, we have that f of A is equal to 1 and f of B is equal to 1. So both of these two elements in the domain go to the same element in its range. Therefore, it is not 1-to-1 because we have two elements in the domain going to the same thing in the range. We need these to be unique if it's 1-to-1. Finally, if it's both onto and 1-to-1, F is called a 1-to-1 correspondence. Now, what this usually looks like is basically the things in the domain and the things in the range, they have the same number. And each thing goes to exactly one other thing in the range. So it would look something like this, where the element 1 in A goes to element 1 in B, or 2 in A goes to 3 in B, and 3 in A goes to 3 in B. Basically, everything in the range is being mapped to, or everything in B, I should say specifically, is being mapped to, and all those things are different. So you'll never find f of A and f of B going to the same thing. So that's a 1-to-1 correspondence, and the best way to do this is just to draw everything out. So the last thing I have, this is a complicated slide, but this is weird for me to say this, but the amount of information here is not as complex as it seems. Basically, all of this stuff is just a fancy way of saying there's this thing called a characteristic function. And a characteristic function is a sorting function. and it sorts elements into two things. Either it sorts it into being true or sorts it into being false. So an example here is I have a visual function is a vowel, and I have 5 letters A, B, C, D, E, and basically, if the element is a vowel, it goes to true. If the element is not a vowel, it goes to false. So, for instance, for is vowel, I ask myself, what about A? And I see here, oh yeah, A is a vowel, it goes to true, so that outcome is true. What if I take the function is a vowel and I apply it to B? Well, B is not a vowel, B goes to false, so it outputs false. So a characteristic function is just a sorting function that takes things to be true or false. And we can give it a fancy name. We can say D is the domain, it maps to two values, true, false. All this fancy notation here, but really this is what we're doing. At the top, I define something called a predicate. A predicate is any function whose range is true or false or 1 or 0. So for our purposes, you can think of a predicate as being just another way of saying a characteristic function. So for instance, the example I gave here is an odd number, and it takes any of the counting numbers from 1 to infinity, and it says either its odd is true or its odd is false. So for instance, if I put odd number 1, it's true because 1 is odd. If I take odd number 2, that's false because 2 is not odd. So we can imagine a big list of numbers. You have a true, false on the right. So every time it's odd, it gets mapped to true, and every time it's false, it gets mapped to F. So that's a very quick video on functions, but this is really all we're doing with functions. Again, it's more abstract and it's something that sets you up for further semantics beyond the course, but also to understand some of the definitions we're giving later. But when we do that, I'll go over functions again in a very, very brief sense, just to bring us back to what exactly this means in the overarching picture of logic and semantics on syntactic structure. So if you have any questions, email me, post on the discussion board, and I'll get back to you when I can.